Welcome to the real curriculum. So let's look at another area where the componenting is applied. We have friction. You know that the friction of a body on another body, because friction is the contact force between a body and another body, between two surfaces. So this body of mass m is on this horizontal ground, and the friction here is not being neglected. The friction is going to oppose the motion of this body. So if this body is accelerating by A or accelerating at A in this direction horizontally, the friction will act, the frictional force, let's call it Fr, acts opposite the direction of motion. So we know that friction is proportional to normal reaction, and normal reaction, from the word normal, is a perpendicular force to the surface of contact. So if first I'm going to draw perpendicular to the surface of contact is my normal reaction. So the frictional force is proportional to it. And in this situation, in this horizontal situation, since the weight of this body is acting downwards, and it is the mass of the body times the acceleration due to gravity, which we are going to call G, then this arrow, by equilibrium of forces, since the body is not moving upwards or downwards, only horizontally, is going to be equal to the mass times the acceleration due to gravity. Is going to be equal to the weight of the body. So automatically the frictional force will be proportional to mg, since mg should be equal to the normal reaction. Then Fr will be equal to the coefficient of friction times the weight of the body. Opposed to the inclined plane situation, you have a body sliding downwards at acceleration A. Its friction will be acting opposite to that direction. Then its normal reaction is going to be perpendicular to the contact surface. Its weight, however, is going to be acting downwards, m times the acceleration into gravity, where its mass is m. So let me make this clearer. So you have the weight acting downwards, you have friction acting this way, it's accelerating downwards this way, normal reaction is acting this way. All right. So we know that, as opposed here, the normal reaction is not more equal to the weight of this body, because they are not more upward and downward forces that are equal to themselves because of equilibrium. It's now a different case here. You can see that the normal reaction is acting in a different direction, in a different axis compared to the weight. So in this case, some mathematics will be done. So the only thing that we need to understand here is that the normal reaction is a component of this one, because we would find out that the angle here is theta, because quickly, drawing a free body diagram of everything happening there, you have arrow, acting like this. You have the inclined plane direction like this, the horizontal angle theta. So we know that here is perpendicular to the horizontal because this is the width line, the width axis. So you see it's perpendicular to the horizontal. It has to be, because the width acts vertically downwards. So here is 90 degrees. We know that here will be 90 minus theta because it's complementary to this in this right angle triangle. This is another right angle triangle. Is another right angle triangle. And we know that here is 90. So here is 90 and here is 90 minus theta. Automatically here will be 90 minus 90 minus theta to give us the rest, because the whole of here is 90 and here alone is 90 minus theta. So here should be 90 minus 90 minus theta. Automatically it gives us 90 minus 90 plus theta, 0 plus theta. So here is theta, as you can see there. So wiping this off, we find out that Rho is just the component of mg, because mg is the force, or is the vector that we're looking for its components, and we're looking for its components along this axis, so that when we find it we can always say that Rho is equal to it. So the component of mg along this axis, since the axis is the one making this theta with mg, is the cos component, mg cos theta. Then its sine component is going to be necessary in this analysis because it's going to be useful, it's going to be something else. So we know that its other component is going to be the one that is going to be parallel, that is going to be along the inclined plane, is the one perpendicular to it, is going to be mg sine theta, the sine component of this. So we now see that Rho is equal to mg cos theta, and this mg sine theta is necessary because it is the force that the body is sliding down with, or sliding down by, because it is the force acting in the same direction as the acceleration the body is using to slide down. So it is the force sliding the body down at that acceleration E. So it's an important component in this situation. So R is equal to this. So the frictional force automatically is equal to the coefficient of friction times the normal reaction. This law still holds. The only difference is that in the inclined plane, Rho is not equal to mg. Rho is now equal to mg cos theta. So the frictional force will be equal to coefficient of friction times mg cos theta in this case. So we know that the frictional force, if we talk about the two aspects of friction, the static friction and the dynamic friction, we know that in the static friction, where the body is just about to move, we can assume equilibrium, that the frictional force is equal to the force of motion. So in that case, for static coefficient of friction, coefficient of friction, okay, first of all, coefficient of friction will be equal to Fr over mg cos theta. But now static coefficient of friction will be equal to Fr would now be equal to mg sine theta from equilibrium, as I said before, mg sine theta over mg cos theta. So mg cancels mg. Sine theta over cos theta is tan theta. And you find that static friction is equal to tan theta. We know that friction is equal to normal reaction, is equal to coefficient of friction times normal reaction. So we just need to find this frictional force, and what we just need to find is this normal reaction, and we know the normal reaction is acting perpendicular. That's why it's normal. Normal means perpendicular to, so perpendicular to this surface. So from what we did before, we know that the weight of this body is acting downwards as mg, then it's its components that is going to be equal to the normal reaction, and its component in this direction is mg cos theta. So we know that Fr is equal to mu mg cos theta. We know that a component of this weight is going to be acting downwards in this direction, and we know that that's mg sin theta. So mg sin theta and this frictional force are acting downwards. So the total force acting downwards should be this force times this frictional force plus mg sin theta, which will be mu mg cos theta plus mg sin theta, and that will be mg. Common mg from the two comes out, then we have mu cos theta plus sin theta, and that's A. So these are things that would most likely not be told to you in school. So like and hit the subscribe button, so I'll be encouraged to do more for you in particular. Thank you very much.